All right, welcome. Today we are going to build something from the ground up. We're going to demystify the entire world of code, and we'll use Python as our construction kit to create our very first blueprint for, well, talking to a computer.
So let me ask you a question. Have you ever wanted to tell a computer exactly what to do? And I don't just mean by clicking icons and buttons. I mean giving it your own custom instructions for any task you can possibly imagine. Well, that's the very core of programming, and it's precisely what we're going to dive into.
Okay, let's get into it. Every great project, it always starts with a blueprint. For us, that means we're going to take a simple idea and turn it into a set of instructions a computer can actually understand and, follow.
So, what even is a program? At its heart, it's really just a list of instructions, a step-by-step guide that tells a computer how to do something. And that something, that computation, doesn't have to be some crazy complex math. It could be as simple as searching for a word in a document, changing a picture, or, as we're going to see, just printing "Hello World" on the screen. Now, in Python, there are basically two main ways we can give these instructions. The first is what we call immediate mode. Think of it like using a calculator. You type one thing in, like 1 plus 1, and you get an immediate result back. 2. Simple. Then there's script mode. This is more like writing out a full recipe before you start cooking. You write down all the steps in order, save them in a file, and then you tell the computer, okay, go run this whole recipe from start to finish. And here's what those two modes actually look like. Over on the left, you've got immediate mode. See how you're typing commands one by one and getting instant feedback? Super useful for quick tests. And on the right, that's script mode. We've saved all our instructions into a file. This one's called hello.py, and we're running the whole thing at once. One is for playing around, the other is for building something that lasts. So now that we have our blueprint, we're going to need some raw materials, right? In any construction project, you need your wood, your nails, your concrete. Well, in programming, our materials are the basic building blocks of data that our instructions are going to work with. First things first, we need a place to put all our stuff. And for that, we have variables. The easiest way to think of a variable is just as a labeled box. You can put something inside the box, and then you slap a label on it, maybe something like message, so you can easily find it and use it again later. So, how do we make these boxes? We use something called an assignment statement. It sounds fancy, but it's really simple. An instruction like message equals hello world does two things. It creates a new box, a new variable, and it gives it a value. So in this case, we're making a box, labeling it message, and sticking the text hello world inside. Easy enough? So what kind of materials can we actually put in these boxes? Well, Python can handle all sorts of things. We've got text, which programmers call strings, like hello. We have whole numbers, which we call integers, like the number 17. And we've got decimal numbers, called floats, like 42.0. These are pretty much our most basic data types. Okay, but what's really cool is how we can shape and change these materials. For that, we use tools called operators, and you probably already know them. The plus sign adds things, the minus sign subtracts, and so on. These are the absolute basic tools we use to start doing actual computations with our data. All right, so we've got our blueprint, we've got our raw materials. Now section 3 is all about the assembly instructions. This is where we start using logic to put everything together and make our code not just work, but work smart. And the absolute key to efficiency here is the function. Seriously, think of functions like pre-assembled reusable parts. Instead of building, say, the same window frame from scratch over and over again for every window in a house, you design it perfectly once, and then you just install that same part wherever you need it. It saves a massive amount of work.
In our code, this process has a few parts. First, there's the function definition. That's where you create the blueprint for your reusable part. Then, later on, you have the function call. That's you telling the program, hey, go grab that part and use it right here. And the result of that is the function output you see down at the bottom.
Now, I've got to show you a rule that is so important and pretty unique to Python. As our source material says, Python doesn't use brackets or special words to mark where a function begins and ends. Instead, it relies entirely on indentation. Yep, that white space. The spaces you put at the beginning of a line. It's not just for looks. It's actually part of the grammar of the language. And if you get this wrong, your whole program breaks. For example, look at this.
Because this print statement isn't indented, Python has no idea that it's supposed to be part of the function above it. It gets confused and just throws up its hands and gives you an indentation error, basically saying, hey, I was expecting this line to be pushed in a bit.
But check out what happens when we fix it. By simply adding a few spaces, an indent, in front of that print line, the code suddenly understands. It sees, okay, this belongs inside the function. And just like that, it runs perfectly and gives us exactly what we wanted. In Python, you gotta keep it neat.
Of course, great builders, they don't make every single tool themselves from raw metal. No way. They use specialized toolkits. And in Python, these incredible pre-built toolkits are called modules.
So what's a module? It's really just a file that's packed with a whole collection of related pre-built functions. And you can bring all of those tools into your own project with one simple command, an import statement. For instance, just by typing import math, you suddenly have access to a massive toolbox of powerful mathematical functions.
And here's just a tiny taste of what you get from that math module. Need to find a square root? There's a function for that. Need to calculate one number to the power of another? Yep, there's a function for that too. Functions for rounding a number up or rounding it down? You got it. This is amazing because it saves you from having to figure out how to write all these complex operations from scratch.
So let's kind of zoom out and bring this all together. We've seen the blueprint, we've seen the materials, we've seen the tools. What's the big takeaway here? Why is Python such a fantastic place to start your building journey?
Well, it really all comes down to the power of those ideas we just covered, especially functions. Using them just makes your code so much easier to read. It completely eliminates repetitive code, making your programs smaller and way cleaner. It makes fixing mistakes, what we call debugging, so much easier because you can just test one little part at a time. And maybe most importantly, it lets you build up your own library of reusable components for all your future projects.
So there you have it. We've walked through the fundamentals, you've seen the blueprint, you've seen the materials, and you've seen the tools you need to get started. The only question left is, what are you going to build first?